Welcome to the video Mass Spectrometry Simplified. In this short video, you will learn what is mass spectrometry and a simplified version of the analytical process. The basic function of an MS detector is to measure the mass-to-charge ratio of ions. Mass spectrometry can be used to identify unknowns, quantitate known compounds, or confirm chemical structures. The unit of mass used in mass spectrometry is referred to as the Dalton. 1 Dalton is equal to 1/12 of the mass of a single atom of carbon-12. This follows the accepted convention that an atom of carbon-12 has exactly 12 atomic mass units. The MS detector does not directly measure molecular mass, but the mass-to-charge ratio of the ions. Most ions encountered in mass detection have just one charge. When talking about mass spec as a process, we are talking about 4 distinct phases within that process. The first phase is to generate ions. The next phase is to move them from the source to the analyzer. The third phase is to select the ions of interest. The final phase is to detect the ions. The first phase in the process is to generate ions. This is accomplished using a technique called heated electrospray ionization, or HESI for short. HESI transforms the ions in a solution into their gaseous phase by using a combination of heat and voltage. When this occurs, the droplets of solution shrink due to a process called desolvation. This continues to occur until the ions are small enough and have the proper charge to be drawn into the transfer tube. The second phase involves moving the ions through the transfer tube to the detector. At this stage, the ions and any remaining particulate travel through what is called a pre-filter. In the pre-filter, neutral molecules are removed from the sample before making their way to the quadrupole. In the third phase of the process, the appropriate ions are selected for detection by 4 electrically charged rods called a quadrupole. In the quadrupole, each opposing pair of rods are connected electrically. As ions move between the rods, the charge on the rods determines which ions will make their way to the detector. The final phase of the process is to detect the ions. Detection is performed by an instrument called an ion detector. On its own, the detector would not be able to measure a single ion. To make detection possible, a second tool called an electron multiplier is used to amplify the response from an ion. The amplifier works by creating a cascading effect of electrons when an ion strikes its surface. The response of the multiplier continues until the ion can be detected. When the process is complete, the results are plotted on what is referred to as a mass spectrum. The mass spectrum represents the abundance of ions versus the mass-to-charge ratio of each type of ion. Based on the results of a mass spectrum, a scientist can identify unknowns in a solution or quantitate known compounds.